This is the 7th video presentation for the CASE Ag Power and Technology course. As you view this video, be sure to make notes of important information. Feel free to pause, repeat, and resume the video whenever necessary. Viscosity, Lesson 3.3 Fluid Material. You prepared coolant solutions during Activity 3.3.2, Keeping Cool. This presentation contains information about a different physical property of fluid known as viscosity. Viscosity is how resistant a fluid is to shear forces as an object moves through it. Shear force is the force applied to objects as each move parallel to each other. As the water flows around the boat, it slows the boat down. Viscosity of a fluid is calculated by finding how fast a round object falls through a fluid while being pulled by gravity. The calculation has multiple variables that are measured and used in an equation. Each variable will be discussed throughout this presentation. Gravitational force is a known constant. The radius and density of the object falling through the fluid, the density of the fluid, and the terminal velocity all must be found before calculating viscosity. Be sure you record the equation and all variables listed here as you will use them throughout the sample problem demonstration in a moment. All objects have gravitational force. The Earth's large mass places a force on all objects, giving them weight and causing them to accelerate as they fall. As an object falls, it accelerates at 981 centimeters per second squared. The radius of the round object, along with the density of both the object and fluid, are calculated before finding the terminal velocity. Gravity will not cause an object to accelerate forever. Once the shear force of the fluid acting on the object is equal to the gravitational force, the object will stop accelerating and travel at a constant speed called terminal velocity. Viscosity of a liquid is found when the velocity of an object increases. The greater the viscosity, the slower the speed of the object that moves through it. These values represent a sample fluid that we will calculate the viscosity for. Remember that gravitational force is a known constant. It will always be expressed as 981 centimeters per second squared. The other variables are found through taking measurements. To calculate viscosity, follow these steps. First, look at the equation used to calculate viscosity. Replace the variables with the numbers that they represent, shown in the table in the upper left corner of the screen. The equation should read 2 times 1/10 squared times 981 times the expression 2.7 minus 0.87 divided by 9 times 3. Using a standard order of operations, you will complete the subtraction within the parentheses first. 2.7 minus 0.87 simplifies to 1.83. Next, you will square the radius. 1/10 squared results in 1/100th. Next, complete the multiplication of expressions in both numerator and denominator. 981 times 1.83 is 1,795 and 23/100ths. 9 times 3 is 27 for the denominator. Then, complete the multiplication in the numerator. 2 times 1/100th times 1,795 and 23/100ths equals 35 and 9/10ths. Finally, divide the numerator by the denominator to solve for viscosity. 35 and 9/10ths divided by 27 equals 1 and 32/100ths. Through this process, we learned the viscosity of the sample fluid is 1 and 32/100 grams per centimeter second. As a review, mark or highlight 3 key points in your notes that are important to remember from this presentation. List 2 ideas or concepts that relate to previous knowledge. List any questions you have about this topic. Discuss these questions with your instructor. Keep any notes you have from this presentation organized and available for use throughout the course. Through activity 3.3.3 Oil Flow, you will calculate the viscosity of different oils at varying temperatures in order to understand how temperature influences physical properties of fluids. Your teacher will provide more instructions for the activity.